So now, let us now focus on measuring area. Now imagine when people wanted to measure area, they had to define a standard for it. Maybe we should have a brief discussion on why would they want to measure area. A simple example is, let's say there is a river valley, right? And it's very fertile, and therefore land has been divided between different farmers to cultivate. And generally these river valleys flood regularly, right? So let's say the next year there was a flood. Now what will happen? All the markings are gone. Now you have to remark them, is it not? You have to claim the same amount of land again and so on. So therefore there was a great need for measurement of area. So let us look at how we measure area now. So first what we do is we define a unit. Okay. Let's say, I'm just roughly making it. We take a square, which is say 1 centimeter by 1 centimeter. Okay, so the square, all the sides are 1 centimeter. Then the area it captures on a flat surface, this area, is called 1 square centimeter. Now this becomes your unit. Of course, if you wanted a smaller unit, then you could have taken a smaller square, let's say of 1 millimeter size, and then the area would have been 1 square millimeter. If you wanted a larger one, you can take a meter, and then 1 meter by 1 meter would be 1 square meter. Okay. Now generally when we are discussing, we can't really take 1 meter, isn't it? So we just make some square and we say, okay, fine, consider this to be a square and consider that each side is 1 meter. Then all the area captured on a flat surface which has this square is said to be 1 square meter, right? Now suppose you have to find the area of something which was as simple as say a rectangle. How would you go about finding it? Let us discuss that. So here we have a few rectangles. Let us consider that each square is only 1 centimeter by 1 centimeter. Of course, the actual size is a little more, but we are looking at the concept, not the actual measurement. Alright, so let us look at the first rectangle. Now in this rectangle, each square is 1 centimeter by 1 centimeter. So what is this breadth? 2 centimeters, right? 1 centimeter here and 1 centimeter here. What about the length? 1, 2, 3. So the length is 3 centimeters. Now we know that the area captured by any one of this square, let's say this area, the area captured by this particular square is 1 square centimeter. Now how many such squares are there? 1, 2, 3, and there are 2 such rows, is it not? So the area of this is going to be 6 square centimeters. Of course, you know that the area of a rectangle is length times breadth. Have you thought why? Why is the area of a rectangle length times breadth? See, that is because if you look at the length, you get to know how many squares are there lengthwise. If you look at the breadth, you know how many squares are there breadthwise. Therefore, if you do length times breadth, you just get to know how many squares are there in all. For example, here there are 3 squares in the first row, 3 squares in the second row. So totally how many squares? 3 times 2. So 6 square centimeter. In a similar manner, let us look at another rectangle. Now this rectangle has 1, 2, 3, 4 centimeters along the length and 3 centimeters along the breadth. Generally the longer side is named the length and the shorter side is named as the breadth. So this is 4 centimeters and this is 3 centimeters. So how many squares will be there inside this? 4 and then 3 such rows. One row has 4 and you have got 3 such rows. So 4 times 3. So this will be 12 square centimeters. Again, you can see the formula length times breadth works pretty well. And it is good to use the formula, but we should understand where the formula has come from, what is the origin of the formula. Okay, let us look at our last figure, which of course is a square, and each side is 4 centimeters. So now see, first row has 4 squares and there are 4 such rows. So what is the area? 4 times 4, or you can say 4 square. Now that is also the origin of why the area of a square is taken as length square. And the same logic will continue even if you had say something like say 2.3 centimeters by 3.2 centimeters. Now, even though there are decimals, how? Well, 2.3 centimeters is nothing but 23 millimeters. Similarly, 3.2 centimeters is 32 millimeters. Therefore, it could be considered as a grid which has 23 millimeters on one side, and on 32 rather on the longer side, and 23 on the other side. Right? You don't have to draw it every time. I'm just telling you how to visualize, even if it comes as a decimal. So that is the origin of why the area of a rectangle is length into breadth, and why the area of a square is length square.